Okay, so we are going to do the demos of the test for the Special Senses Lab. We are going to show how to do the test for vision, hearing, and equilibrium. And I have recruited 2 willing, fantastic subjects who hopefully don't break any equipment.
Don't throw the equipment.
I brought the equipment home with me, and I have recruited them because they're home from school, so they're going to learn some physiology. Here I have Emilio on my left. Here I have Lola on my right. Okay, so the idea is for you guys to get familiar with how the tests are done, the type of data that we collect from it, and how to interpret that. And I'm going to use, going straight from our lab manual, I'm going to do the exercises so you can even step right through and kind of watch with this little YouTube tutorial. Okay, so the first one is the Snellen eye chart. Okay, my subjects need to cooperate. There we go.
Okay.
The Snellen eye chart for visual acuity. Okay, so we have it set up here. We don't have the greatest light happening, but there's the Snellen eye chart. Going from top to bottom, and if you look very closely, it says, here's this row 2. If you can only make it out with a minimum number of mistakes to row 2, you have 20/100 vision. That means you see at 20 feet what somebody else sees at 100 feet. If you can make it all the way down to where most people do, average is 20/20, right? And you do one eye at a time. That means you see at 20 feet what the average good clear vision person sees at 20 feet. Okay, so you guys have all probably done the Snellen eye chart at an eye exam, and many of you probably have prescription glasses. So we're gonna let Lola be the experimenter and Emilio be the subject. Take it away.
Number 1, row 1.
E.
Lola, don't shine the light though, just point.
Okay.
HN. DFN. PTXZ. UZ. DTF. DFN. PTH. PHUN. T. DZ. DZ.
Yes.
There you go.
Best guesses.
N. The middle one's T. The last one is Z, I think.
Okay, you have 20/20 vision.
Yeah.
All right, 20/20. So with the last line that you can get with the minimum number or no mistakes, that's the vision. Okay, so now we're going to go to, Lola's going to let him do the astigmatism chart. And if we look, we have this chart up. You have to stand for the Snellen eye chart visual acuity, how much detail you can make out. You stand 20 feet away.
Stand at the tape.
For the astigmatism, you stand 10 feet away. I have tape on the floor so they know where to go. We're in the kitchen. Slightly awkward. Okay.
Do any of these look bold to you? Like one big line?
No, they're all 3 lines.
They're all 3 bars?
Yeah.
Okay. Perfect.
All right, so all the way around the little pinwheel here with the spokes. If you have an astigmatism in any plane of your eyeball or visual field, usually it results from asymmetries. These lines would look thick wherever they are. Maybe over here versus over here. They would look like one thick, bold line instead of 3 separate ones. He doesn't have an astigmatism, so he's a negative test result here. No astigmatism based on the astigmatism chart. Okay. Okay. So the next test we are going to do, and I'm actually stepping right through, and I'm going to show you right in the lab manual here, mine. We just did the experiments, visual acuity, 20 feet, got the reading, and it was 20/20. Okay. And astigmatism chart, he has no astigmatism. Okay. So the next one we're doing is near point of accommodation. Okay, and this has to do with the elasticity of the lens, and as you age, the lens gets less elastic and it's more difficult for it to flatten out and view distant objects and then bulge up and view near ones. So the near point of accommodation is how close an object has to be from your eye so you can still focus on it and it doesn't get blurry. Okay, so near point of accommodation, Lola, you want to administer to Emilio, and then he can administer it to you, so you guys can see how we actually do this. We use a ruler, this is kind of a rubber ruler, so it doesn't hurt. You put it right on your eyeball, and we got a little A. We've got the letter A, and try not to jam it in his eyeball. And
no promises.
yep. And she's going to slowly move it until it gets to a location where it gets out of focus. It gets blurry. He's young. He's 11. So his near point of accommodation is going to be fairly close, and his lens has great elasticity to kind of bulge up and view close things. Right about there?
Stop.
Okay, perfect. Now look at the ruler, exactly where it
Okay,
is.
so 6 because I had it flipped around.
Okay, so that was 6 centimeters. So if we look at the results, so basically, I would say visual acuity, it's hard to do this and write, 20/20. And then the right eye was 20/20. Oh my gosh, it's weird to watch myself write like this. Left eye, basically negative for astigmatism. Right eye, negative for astigmatism. Accommodation. All right, so your near point of accommodation, we just did them both together. They did both eyes separately, but was it 6 centimeters?
Mm-hmm.
Okay, so his is super small, actually. Okay, so if we look at the lab manual for the section on how to do this, the near point of accommodation, if we look at age right here versus near point, for me, I'm right about in here. I'm still at about 18 centimeters. He's close to 10, and his was it 6? So yours is under average. So the average near point of accommodation for a 10-year-old is 9 centimeters. All of my students, all of you guys, will be close to about 10 centimeters or somewhere in this range. You can try doing this on your own. These are really easy. All you need is a piece of paper with a letter on it. You can even handwrite it, and a ruler. All right. So Lola, did you do the near point of accommodation? Amelia, you want to administer it so she can do it? We can see what hers is.
Let go.
You're getting along really well. Thank you. We have a longer ruler that kind of, it's real malleable and like flexible, so it doesn't hurt. It's not
Left eye.
sharp, but just whenever you do this, just be careful. You can do both eyes open or one at a time. It's up to you. If you have different vision, different visual acuity in the eyes, you can do them separately. But you guys have 20/20 vision. Go slowly until it gets out of focus. Real slow, not too fast.
Stop.
Okay, now read it. Mark on there.
It's 23.
And you have it backwards, so that's
So
okay.
7.
So it's about 7 centimeters. Okay, so for yours, Lola would be about, yeah, you guys are both about 6 or 7. You guys are really close. You're above average, actually, so pretty good. All right, so the next one we're going to do is binocular vision. We, as human beings, we had a discussion about this, right? You said you didn't have a blind spot.
I'm the superior human.
She says she's superior, so she doesn't have a blind spot, but I convinced her she has a blind spot. So we have stereoscopic vision. That means we have 2 eyes that are facing sort of forward, which means we have an overlap of the visual field. So our visual field gets processed by both of our eyes, but we also have a blind spot. So this gives us depth perception, but when using one eyeball, you actually have a blind spot. So the blind spot is compensated for from the left eye by the right eye, and the blind spot in the right eye is compensated for by the left eye. So you can reveal the blind spot by covering one of your eyes and looking at 2 different objects or writings. In this case, it's right in your lab notebook, and here we have a separate card, but you can even use it right in your lab manual. And it's an X and a dot in this case. So you're going to want to focus on the X when you do this activity. I did it right here in the book during this, so we just did blind spot. Sorry, we just jumped way ahead. Should we do blind spot first?
Mm-hmm.
Sorry. I just jumped ahead. Now, let's not do blind spot first. I'm going to try to stay in the right order. So astigmatism, sorry, near point of accommodation. I jumped ahead. I got excited. And then binocular vision. This is where I started. Okay, so binocular vision, we have stereoscopic vision, both eyeballs, right? And the blind spot we're going to test in just a second, and it's related to this. But the binocular vision allows us to see with great depth perception, but one of your eyes is typically more dominant than the other. So Lola is going to actually show how this is done. We use the little cubes that we've used in the scientific lab at the very beginning. If she holds it about 3 inches from her face, and she's focusing on the cube. Let's see if I can get a good, okay. Now she's going to close one eye, and then open the eye, and then close the other eye, and then open that eye, and close the other eye. And the cube is going to move. It's going to kind of jump. And it's going to jump less, or move less, when one eye is closed and opened compared to the other eye.
This side.
So for Lola, it's her left eye. Whether she closes it or opens it, the cube in her visual field moves very little. It kind of stays put. That's her dominant eye. So the right eye is not the dominant eye. And so when she closes and opens her right eye, the cube visual kind of moves back and forth. And so you can try this with anything, with a die or a cube or something that's small that you can focus on. Okay, so I will write that down here. So after binocular vision, basically it's right eye view or left eye view, and her left eye view, she's the dominant eye. Right is the non-dominant. That's what I would just kind of write it down. Okay, as. So her left is the dominant eye. It moved very little when she closed and opened her left eye. Okay, so I'm going to stop. We're going to do a separate little segment on the color vision tests, and we're going to break these up into 3 short little kind of demos. Okay, over and out.